Rational function, communication and thinking problem. C6. Determine the equation for horizontal asymptote for fx equals to 1 minus 2x minus 1 over 4x minus 1. This is a very interesting question. I would like you to do it. Stop the video at the moment. And once you have solved, then look into my solution, okay? I'm trying to solve this in two different ways for you. Okay, so let me just draw a line here, right? One way I'll do is, I'll write it as one function and then show you what the horizontal asymptote is, right? So I can write f of x as equals to, so 1 minus 2x minus 1 over this. So instead of 1, I'll write 4x minus 1 because I need common denominator, right? Over 4x minus 1. So that is 1 for me, right? So I'm multiplying and dividing 1 by 4x minus 1 minus 2x minus 1 over 4x minus 1, correct? Now 4x minus 1 is my common denominator, and I have 4x minus 2x as 2x, and minus 1 minus of minus 1 gives me 0, so 0, so it's just 2x over 4x minus 1, right? Now if you have a function like this, you know, as x approaches infinity, minus 1 is a very small number, right? So the function, so what we say is that as x approaches plus or minus infinity, right? So f of x actually approaches 2x over 4x. Is that okay? So that gives you the horizontal asymptote. That's the basic definition of horizontal asymptote, right? That's how you get it. And therefore normally we say that if the degree of numerator and denominator is same, then the equation for horizontal asymptote is ratio of the leading coefficients, right? So you know, horizontal asymptote for this is therefore y equals to, horizontal asymptote is always y equals to, right? Where the y value is constant all along, right? 2 over 4, right? The ratio of leading coefficients. So 2 over 4, which is same as half, right? That's your answer, which you get from here also. So horizontal asymptote is y equals to half, correct? Now remember, this I did to remind you the basic definition of horizontal asymptote. What is it? When x approaches plus infinity, then f of x approaches a fixed value, then that value of f of x is the horizontal asymptote. Or if x approaches minus infinity and f of x approaches a fixed value, right, then that value is the horizontal asymptote, right? In this case, both sides, whether it approaches plus infinity or minus infinity, f of x approaches half, and therefore y equals to half is the horizontal asymptote, okay? So that's the way, that's one way we can do it, right? And here is an alternate method, right? Let me write alternate method here. I know I'm going from this side to this side. Somehow, sometimes find it more convenient, right? Now, here we'll use this principle, that is, the degree of numerator and denominator is same, and therefore equation of horizontal asymptote should be ratio of leading coefficients. But we see from transformation that f of x is 1 unit translated up, right? So this horizontal asymptote gets a unit translated up. Do you see that? So that is what we are going to look at, right? So let me write the equation again to explain you my point. The function is fx equals to 1 minus 2x minus 1 over 4x minus 1, correct? Now, this means what? What is the meaning of this 1? When you add 1, so what is really happening when you add 1? When you add 1, then the value of f of x increases by 1 all over, right? So that is like translation, right? Of 1 unit up, right? So this is 1 unit up, and therefore this horizontal asymptote gets translated 1 unit up, right? So if you consider only that part of the function, in that case, you know, from here the horizontal asymptote should be ratio of these two, right? So let me write small horizontal asymptote, okay? Which will be minus of 2 over 4, which is minus of half, correct? But since our function is not just that, but the function is this plus this, therefore our horizontal asymptote will be y equals to 1 minus half, which is half. Do you see that? The same answer. So that is the way to look into it as a transformed function, right? So therefore, horizontal asymptote for the given function is y equals to half. Either way do it, okay? Thank you.